Outlier visualization in Python. Welcome to this beginner-friendly lesson on spotting and visualizing outliers in your data using Python. Outliers are values that are much different from most others in a dataset. They can help you find mistakes, rare events, or patterns you might miss. Today, you will learn how to find outliers and make simple visualizations to better understand them. Let us get started. Running the cell now. Remember, if you enjoy this video, like and subscribe so you do not miss the next one. We start by bringing in useful packages. The random package helps make example data. The matplotlib.pyplot2 package lets us make charts. Running the cell now. Try typing these lines into your notebook. Practice importing these packages a few times. Here, we make a list of 30 numbers between 10 and 20. This gives us a small set of pretend data to play with. We print it to see the numbers. Running the cell now. You can change the range or amount if you want more data. To learn about outliers, we add 3 numbers that do not fit, 45, 50, and 2. We make a new list with these outliers at the end. Printing helps us check if the outlier values are added. Running the cell now. Try adding different numbers as outliers to see how results change. What is an outlier? An outlier is a number that stands out because it is much smaller or larger than most data points. Finding outliers helps us avoid mistakes, fix errors, or see surprises in our data. Let us look at our data visually. Running the cell now. We make a scatter plot to see each data point. The plot will be wide and short, so outliers are clear. We use blue dots for each value in our list. The chart gets a title. The horizontal axis is the index, just the order in our list. The vertical axis is for the value. Now, the plot will pop up so we can look at outliers. Running the cell now. Try finding the outliers in the plot by eye before we mark them. Now we will use a simple rule to spot outliers. We bring in numpy, a package for numbers. We find the value at the 3rd percentile. Below this is very rare. We find the value at the 97th percentile. Above this is rare too. Outliers are anything below or above these cutoffs. We collect these special numbers. We print our cutoff values. We also print the outliers we found. Running the cell now. Practice, can you change the percentile values? Try 5 and 95. Let us make a new plot to show outliers. First, we find which positions have outlier values. We make the plot wide and short again. Most points are blue and mean they are normal data. Red points show the outliers we found. The plot gets a better title. The horizontal axis stays the same. The vertical axis still shows value. We add a legend, which is a label for colors. Now run it and see which points stand out. Running the cell now. Can you think of real-life data that could have outliers like this? Why do outliers matter? Outliers can mean a data entry mistake, a rare event, or something interesting to study. If we ignore outliers, we might get the wrong idea about our data. Sometimes, though, we want to remove them for certain calculations. Let us see how to do that simply. Running the cell now. Like what you see. Do not forget to like and share this video with a friend. We now make a new list where we keep only numbers inside our safe range. This list has the outliers removed. We print the new clean data so you can compare. Running the cell now. Try running calculations with and without outliers to see the effect. Let us look at our new clean data. This plot only shows numbers without the outliers. We use green color so you can tell it is different. The title makes it clear this is clean data. The horizontal axis shows index again. The vertical axis shows the values. Look for the missing extreme points. Running the cell now. Notice how the plot looks different without the extreme numbers. Now we use a new chart called a box plot. Box plots show the range and highlight outliers with dots. We use horizontal style for easier reading. The title and axis label explain what we see. Run and look for single dots far away from the box. Running the cell now. Box plots are used a lot in science and business for a quick outlier check. Next, we use a new sample created from a bell curve like real-world numbers. We add a few strange small and large values. We make another box plot, this time in orange for variety. We change the title so it is clear this example is new. The axis label still shows value. Box plots make it easy to spot when something is odd in your data. Running the cell now. Challenge: make your own sample with wild outliers and see how the chart changes. We can use another popular rule, the interquartile range, or IQR. Q1 is the 25th percentile, or where lower fourth of data stops. Q3 is the 75th percentile. IQR is the difference between these points. We set a lower bound as Q1 minus 1.5 times IQR. We set an upper bound as Q3 plus 1.5 times IQR. We look for values outside this zone. We print any outliers found with this stricter rule. Running the cell now. Many textbooks recommend the IQR method for finding outliers. Histograms are another way to see your data spread. Bars show how many times each value or range appears. We use 15 bins, or sections. The title, x-axis, and y-axis make it easier to read. See if the outliers create bars far from the rest. Running the cell now. Histograms help spot strange values and show if your data is lopsided. Now you can take part. Type a number to add to our sample. The chart will show if this number stands out. The plot is just like before. It helps see where your number lands, normal or outlier. Running the cell now. Try a very high or low value for real outlier effect. Here is a small example of room temperature readings. Most are near 20, but one is way above normal at 120. Box plots make that error obvious. Notice the title and the units. This is why it is good to check data before you analyze it. Running the cell now. What types of measurements do you work with that could have errors like this? Let us compare side by side, with outliers and without. We make two charts next to each other for easy seeing. Left shows all data with outliers as blue. Right is green and only clean data. Each gets its own title for clarity. We label the axes in both plots. Just a little formatting so everything fits. The plots appear next to each other. Notice which outliers vanish after cleanup. Running the cell now. Try this trick with your own data for before and after checks. Here is a quick tip. Be careful with plus and minus signs when making range checks. If you type the wrong symbol, your outlier rule might miss or add mistakes. Running the cell now. Practice, try swapping a plus for a minus and notice the effect, then fix it. Here is a challenge for you. These are ages of students, but 99 is suspicious. The box plot helps you see that as an outlier. The chart title and axis explain it. Try fixing or removing outliers in your own samples. Running the cell now. Recap what you learned. What an outlier is and why it matters. Simple Python tools to spot outliers. Making plots to show outliers. Ways to remove or work with them. Real-life problems where outliers happen. Keep on practicing with your own datasets. Running the cell now. Thank you for watching. If this lesson helped you, click like, leave a comment, and share with a friend. Subscribe for more easy Python lessons and data skills. See you in the next tutorial. Running the cell now. Thank you for learning with us. Like and subscribe.